Okay, so we're going to talk about graphs of logarithmic functions now. To do that, we have to start with their domain. So we've talked about rational functions where there's x's in the denominator, and we talked about finding their domain. The same thing with square roots, right? And so logs, the argument of your log has to be positive. So when we're saying log of stuff, all of this stuff in here needs to be positive. That's the argument. So what we do is we make an inequality to set all that stuff bigger than 0. So find the domain of this function 5 minus 2x. So I need 5 minus 2x to be bigger than 0. So remember, we've solved these kinds of equations, these inequalities before. So subtract 5 from both sides. Negative 2x bigger than negative 5. Divide by negative 2. Remember, when you divide by a negative, it switches the direction of the inequality. So x less than 2.5. So if you think about this on a number line, here's 2.5. I want only the numbers that are less than 2.5, and I want an open circle there. So negative infinity to positive 2.5 with a parentheses at 2.5, because I can't put in, it has to be greater than 0, not greater than or equal to. And so what does that look like in terms of the graph? Well, in terms of the graph, we get what's called a vertical asymptote. Oops, that's a typo there. A vertical asymptote at x equals 0. So this line here is a line that we get really close to, but we never cross, okay? So what that does is that makes our domain from 0 to infinity. But now our range goes from negative infinity to infinity. So if you think back to exponential functions, this switches the domain and range of an exponential. Because they're inverses. Okay, I have an x-intercept at 1, 0. I never cross that y-axis because I have an asymptote there. It's increasing if b is bigger than 1 and decreasing if b is between 0 and 1, just like exponentials were. Okay, so here's some examples. Sketch the graph, state the domain, the range, and the asymptote. Okay, in this case, b is 5. So b is 5, so this is going to be increasing. I just have an x inside there, so my domain is going to be exactly like the domain of the regular one with that asymptote at 0. And it's going to cross here at 1, so it's going to look like this. My domain is from 0 to infinity, while my range is from negative infinity to positive infinity. It has a vertical asymptote at x equals 0. Okay, this guy, my b is 1/5. So that means he's decreasing. He's going to be going down instead of up. But notice that my argument in there is still just an x. So I'm still just going to get that vertical asymptote here. He's just going to come down like this instead of going up. So my domain, still the same, 0 to infinity. Range, still the same, negative infinity to positive infinity. And my vertical asymptote, again, is at x equals 0. You could move these around, just like we did with exponentials if you had some transformations, but we're not going to do any